Hi folks, we're back with another interesting question in engineering economy. My name is Dr. Hassan Abul Bashari and I'm a lecturer in engineering economy. So one of the foundational concepts in engineering economy is to understand the difference between the nominal and effective interest rates and how they relate together based on the compounding periods. Let's take a look at this question. This is a question that I designed for one of my exams during the lecture, during the course that was provided in one semester. And I always tell my students, if you're able to get this question right, it means you have a comprehensive understanding of the nominal and effective interest rates and how they relate to each other. Okay, let's take a look at the question. It says mark the correct answer or answers, meaning that there might be more than one correct answer. The question says the monthly interest rate is 1.5% and interest is paid at the end of each month. If you invest $5,000 now, how much will you have after 2 years? Okay, so as I always say, the best way to approach these kind of questions is to go ahead with a visual presentation of the question. So if I'm investing $5,000 now, how much I'm going to have after 2 years? It's a very simple visualization of the question. So in engineering economy, we know that the formula to calculate a future value based on a present value is F equals to, the future value equals to the present value, P, multiplied by the factor of FP I%, which is the interest rate, and the number of periods we have. So in this question, we've been given the interest rate of 1.5%, which is a monthly interest, and interest is also paid on a monthly basis. Therefore, a very straight answer to this question is going to be, as you can see, equal to $5,000, which is the present value, and then multiplied by the factor of FP 1.5% monthly. But then what is the correct N that we have to use, the number of periods in this question? In 2 years, how many months we have? We have 24 months. Because my interest rate is a monthly interest rate, I have to use N equal to 24. So this is a straightforward answer to this question. Looking at the alternatives that the question had provided on the first screen, I can see that my answer is matching the second option there, which is one of the correct answers. Now, let's go and check if we have other correct answers as well. In all the other alternatives that the question has provided, I can see that the N, or the number of periods, is considered as 2. And by this 2, I understand that this 2 means 2 periods here, which is equal to 2 years. If the number of periods I'm considering for this interval is 2, that 2 could only correlate or correspond to years. So the question wants me to come up with the answer, how to write the correct answer if I'm considering 2 years. Now, in order to have 2 years here as the N, the question is, what should I be considering as the interest rate? So the key here is to find the effective yearly interest rate based on the monthly interest rate that I already have and the question has already provided me. So based on the monthly interest rate I have, which I've been provided by the question, what is the effective yearly interest rate? which one of these yearly interest rates are correct? Again, we know that. Okay, so the question is, I need to find the effective annual interest rate. Based on the formula, we know that the effective rate, the effective interest rate, IE, is equal to 1 plus R divided by T, the whole term, powered to T minus 1. Now let's quickly see what do each of these terms mean. So the IE is the effective interest rate, which I'm after. The R is the nominal interest rate, and the T is the number of compounding periods. Now, to find this effective interest rate, the yearly effective interest rate, the IE, I need to first find out what I should be putting for R and T in this formula. The R, the nominal interest rate, because here we're after the yearly interest rate, we should be calculating the yearly nominal interest rate. So the yearly, I have the monthly nominal interest rate, which is 1.5%. But then in a year, the yearly nominal interest rate is going to be 12 times that monthly interest rate, because each year, 1 year, has 12 months in it. So the nominal yearly interest rate is going to be 12 months multiplied by the interest rate of each month. 12 times 1.5% is going to equal to 18%. Now, what about T? T is the compounding periods. When I'm considering the yearly rate, then the number of compounding periods in 1 year is going to be 12. Now, why is that? Because the question had told me that interest is paid at the end of each month, meaning that in 1 single year, I have 12 compounding periods. Therefore, I can go ahead and complete this formula. So it's IE is 1 plus this 18% that I calculated up here, divided by the number of compounding periods in 1 year. So this whole thing, we're going yearly. Everything has to correspond to yearly. So the number of compounding periods in 1 year is 12. So we put on in the data we have, and the answer is going to be 19.6%, which is going to be the effective yearly interest rate, or the yearly effective interest rate. Now, going to back our formula, now that we have calculated the correct I in this formula, we can go ahead and insert the data into the formula, which is going to be like this. So the future value is equal to the present value of 5,000 multiplied by the factor of FP 19.6, which is the yearly interest rate, the effective yearly interest rate. And then the number of periods I want it for, because that's my horizon, that's my time horizon. I have now calculated the interest rate for 1 year, just from here to the middle. Then I want this formula to give me the value after 2 years. So now that I have the yearly rate, I want to know it after 2 years. So this is my correct answer. Now going back to the alternatives that the question had provided me at the first place, that was my first answer based on the previous screen which we went through, and we now know that the second correct answer is going to be this one. So these two equal to the same value. It's just the two different representations of the answer.